Good morning, ladies and gentlemen from sunny Prague. I would like to welcome you on the webinar from the series related to SCIA Engineer 19. And today topic is named Parametric Design using the new OpenAPI in SCIA Engineer. Before we will start with the topic related to the OpenAPI, here are some housekeeping. All attendees are muted, so you are not able to use microphone for asking questions, but you can use the box which is called questions and write or type your question into the box. And my two colleagues which are here together with me, Vladimir and Adam, will reply on the questions. Webinar is recorded and will be published on our official SCIA YouTube channel. As I have mentioned at the beginning, there is a new release, SCIA Engineer 19, and here is a short overview of all the topics which are related to this release. We had the webinar related to what's new. Also, we had a webinar which was related to the concrete design. Today we have OpenAPI, and we will have a dedicated webinar related to the steel and concrete. But today we are here because we would like to present some development which we did related to the parametric design. Let me start with some introduction what parametric design is. That's let's say the approach which is related to the definition of the mathematical relations between some parameters or elements. That's the, let's say, the different approach than normally we are used to when we start the developing model in CAD-like systems or in SCIA Engineer, that we are directly modeling the columns, beams, slabs, etc. No, that's the way of working, that we are creating some algorithm rather than we are the shaping of the structure. Basically, you can imagine it as it is in the picture which you see here, that I have some arc and I have some parameters which I can actively change. And most often way of working in the case of the parametric design is that I have some design goal which I would like to achieve. For example, I'm designing my structure so that there will be the minimum ratio between the weight of the structure and the cost. Or I would like to design my structure so that there is maximum load-bearing capacity. Or if I'm a fan of membranes, I will start to do the design as an form finding, or let's say the minimal internal energy. And there are some other also design goals which I can fulfill, and I'm searching. When we are talking about the parametric modeling, mostly it's also supported with the approach or the tools which are related to graphical scripting or the visual programming. And that's represented by this picture from the Grasshopper, where you have some canvas and you have some components in the pallets. And you are using the boxes to define some objects, and you are using some wires that you are connecting two boxes, and that's the definition of the relation between two boxes. So here that's an output, and here it's an input, so that you are creating relations between the objects or elements. Most of the tools which are capable to do the visual programming, there are also containing some components which can include the code in Visual Basic, Visual .NET, etc. And then some examples of that applications I already mentioned, the Grasshopper, which is part of the Rhino. Currently, you can know it as a connection Tekla structures and Grasshopper, or Architect and Grasshopper. There are also some other solutions like Autodesk Dynamo, Vectorworks, their proprietary Marionette, and also if you are familiar with Outline, you know that there is also the technical preview of visual scripting based on the Python parts. In my future presentation, I would like to mention mainly the tool which is called Grasshopper, and that's the part of the Rhino, because we feel that it's most popular tool which is used by structural engineers, which they want to reach some goal for minimization of the structure, or it could be called, let's say, the informed geometry, that you would like to scale the edges based on the results of internal forces, or you are searching some optimal placement of columns and their connections. As I described on a previous slide, Grasshopper contains some native components, and it could be also, let's say, enhanced by the scripted components. There is a huge community around the Grasshopper, and the community provides a lot of add-ons. Let's name a few of them. That's the Karamba for structural analysis, Kangaroo as in physics engines for modeling of sun or some other physical aspects, and also, let's say, Galapagos, which is a tool related to the genetic optimization. And as we have seen that there are movements related to the parametric design, we decided to came up with our own tool, which is named Koala. It's Grasshopper script components. It uses VBA.NET. Currently, it's support model transfer. That means that you are able to export the model from Grasshopper to SCIA Engineer, as it extracts some informations, and it sends the information directly to SCIA Engineer via XML file. The other possibility, let's say, that's some bidirectional link. That's a possibility to export the model from Grasshopper to SCIA Engineer and run the analysis with the help of SXML tool, and you can obtain the results in TXT output, and based on the results, you can, let's say, do the other cycle of the optimization, or what you would like to achieve. This tool is published on our garage, and you can download it from the garage. It's published on the SCIA Resource Center, and here you can see the page which is related to the Koala, with the brief description, what's the support, instructions, version history, and here you can download it as a zip file and open it in the Grasshopper. I will now start with topic which is related to the parametric design and which is related to the SCIA Engineer 19, and that's the feature which we are calling OpenAPI. Let's start with some brief introduction. What API means. It's an application program interface, and that's, let's say, the set of the functions, procedures, or methods which are used by one computer program to request services from somewhere else. That's what is stated on Wikipedia, and I use this quotation to start the second part of this presentation, which will be focused on our OpenAPI. Basically, there is a question why we started to develop such a feature which is related to OpenAPI. As you have seen before, the Grasshopper and the parametric modeling, which I used for, let's say, the motivation for this webinar, we observe that we are able to write some script components in Grasshopper and using our XML to transport some data, but it's let's say limiting, because let's imagine to create some complex frame and do some optimization, as you can see here on the picture. Here, that's one of our, it's project from one of our users. It's was the contestant in SCIA User Contest 2013, and that's the model which was used in the Rhino, and then it was exported to SCIA Engineer for the further analysis and calculation. We wanted, based on our own experience with Grasshopper, to offer our clients possibility to enhance SCIA Engineer beyond its focus. Beyond means, in the case of the interoperability, that you can develop your own tool, for example, to transfer model from Dynamo to SCIA Engineer, or you have your own tool or application and you want to have the link with SCIA Engineer for better process. That means that you would like to be able to easily extend SCIA Engineer. For example, you also need to have some further checks or design procedures which are not content of SCIA Engineer and goes beyond the capacity of SCIA Engineer. So you can easily extend it, that you will retrieve the results, the calculated results from SCIA Engineer, and based on that, you can create your own tools. In the past, we already had some APIs mainly based on the COM technology, but we wanted to do the unification. And moreover, what's important for us is that the API which we are providing should be easy to use, that you have, let's say, the low entry input to use it, like you will start in VBA scripting, and then you can use the full power of SCIA Engineer as a calculator on the background without any needs to study years of software engineering. So it should be a friendly API which has some easy to use functions. You have seen some, let's say, I'm calling it complex structures, but you can imagine that you would like to use SCIA Engineer for design of such a cooling tower. And then you can think that, well, it will be nice to have it parameterized, so I can choose the diameter here or change it. I can change the diameter here, the height of the structure. It's for at least for me and my knowledge of the geometry, it's very complex of the complex structure for the modeling. It's some hyperboloid, and it's easy to model by hand, let's say, in SCIA Engineer. So why not to use some tool which can generate the model, which can generate the load, let's say mainly the wind load, and you can obtain the results which are displayed here as an example of the wind load acting on such a structure. It's not just for cooling towers. It could be used for the modeling of the bridges or some steel elements where you need to have some, let's say, the freedom of the change, and that's the change is not painful for you. If you can imagine that I would like to change span here, then it will need a lot of changes here, because there are some let's say typical structures, or let's say the steel frames, which needs to be somehow enlarged, and at least for me it will be more painful to do it manually than just at the beginning to think about and create some algorithm which can help me to do it in matter of minutes, not in matter of hours. When we are talking a lot, let's say, about OpenAPI, you may want to ask us what's really included and what's it. And I already mentioned that we think in the case of API that it should be friendly, easy to use. It should be based on the modern technology, that you can envision a day in the future that you will have one computer where you will run your tool that provides a model, and then that model is sent to the cables somewhere else to the cloud system like AWS or something else. Then it's calculated, and maybe the results are retrieved back, or there are some other things on the background. So it should allow us to do it easily somewhere in the day, in the future. So use the modern technology. We have been also thinking which languages are, let's say, mostly used, that the API should work with the various programming languages, starting from C#, VBA as a part of Excel, or VB.NET, Python, PowerShell, you name it. And for me, let's say it's the right moment to ask you to vote which programming language you are using, or you at least know. I will let you vote a couple of seconds. Let's say that the intermediate results, that the fight is between the Python and the VBA. So last 10 seconds from someone who still want to change the vote or to beat the results. So I will close it. I will quickly share it with you. And as you can see, 43% vote of you voted for Python. On the second place, that's VBA. On the third place, that's C#. Surprisingly, VB.NET there is 0, and 8% there are others. So I would like to thank you that you vote in our pool, and we will go through the presentation. So we have been speaking about the programming languages. We wanted to have it for these which are named on the slide, and what's important, that we wanted to have some understandable methods in API, which we will see in a couple of minutes in the action. So if I would like to create node, let's say that the method should be called create structural node. Once I would like to link these nodes with the entity called beam, let's call it the function create beam, etc. Now that's the perfect time to briefly mention what's inside the OpenAPI. Let's say that the feature set, what's possible. Currently, it's possible to run SCIA Engineer, open a project, and save a project. If I have opened an empty project, I'm able to import or update of a model from a file where we are supporting IFC file, we are supporting XML, we are supporting the file which was created as an export from Revit or Tekla. We are also able to update from the SCIA Engineer project. And what's also mentioned here as an XLSX format, that's a possibility to update the model from Frilo exported file, or as we are also calling it from the Excel file, which is based on a structural analysis format. Once I have opened a project, I can create a predefined material from Eurocode just with the usage of the name. I'm able to create a predefined library, cross-section, mainly for steel, or I can create a parametric cross-section. Once I have the material, I have a cross-section, I can create 1D element, or if I will also input the thickness and material, I'm able to create the 2D element. Once I'm done, let's say with the geometry, I can start to add boundary conditions like support and hinges. I can create a load case, and into the load cases I can assign load. Once I have all this done, I can start the linear calculation and get the results of the finite element calculations for 1D element, 2D elements, and also the reactions. Once I told you that we want to have it, let's say, low-level entrance and friendly to use, we created documentation in our help, and we also published some small examples on a GitHub. So you can use help to learn about methods which are in OpenAPI. This is the help which is valid for SCIA Engineer 19. Here you have the topic named OpenAPI. Here you have this short description. What is it about? And if I will click here, I will go directly to the documentation of OpenAPI with the description of the classes, members in the classes, etc. You will see it also live during the demonstration. From the same page, if I will go back in the browser, you can go to the GitHub, which is named SCIA Garage, and here you have the simple examples how to use, for example, OpenAPI with VBA or OpenAPI with the Python. If I will click on the topic, then the page and the repository, it's loaded, and here you can read what you need to do in advance once you would like to use OpenAPI, so that you have to have SCIA Engineer installed on your machine, that you have to have installed the Python 3.7, because the way how we create our example to easy to use, let's say that you have to also install the Python.net package, which enables some functions, and is it to include the DLS from the C#, and here it's how you should start and write the first pieces of the code, and also some troubleshooting once something is not okay with your application. And let's say here, that's then Open API example Python, and that's the simple, let's say the simple script in a Python for the demonstration. What's possible with Open API? Till now, I have been using for my speech the PowerPoint presentation, and also the browser to show something in the web browser. I would like to also show you the program. That's the simple example. It's written in a C#, but I think that it's easy to understand, and I will explain it during the live demonstration. So I have already written some code. Let's say the full program is written and it's compiled, and I will start it. So the first which is done, let's say on the background in the meanwhile, once it's started, it creates an environment for OpenAPI, and you have to let's say write the location of installation of SCIA Engineer, some directory for the temp of OpenAPI, and also some version of OpenAPI. Then it's it open SCIA Engineer with a simple method from environment that it's called run SCIA Engineer, and here you have let's say the capability to say that which, let's say, GUI mode you would like to use. If you have some doubts about the enumeration, so you can go to the browser, and here you can see which possible enums we have, or you can visit the web page and read about it, that you can have the GUI which started on the background, as you can see, just running here, or you have some other possibilities. Once SCIA Engineer is opened, I can open my, let's say, the template projects, because for the smooth run, I would like to use some empty projects which is needed. So I open it. It's just now opening, as you can see here. Once is opened, we will wait couple of seconds. Then I can start with the creation of the materials in OpenAPI. So basically here I am using the console program, so it will ask me to set the grade for the concrete material. Once I'm asked, and then I will use the simple construct to create the material, which is consisting from the unique identifier, which it's a GUID. That's let's say the similar if you are using some databases, so you have some primary key, and so that you can reference it. Then it's the name which will be visible in SCIA Engineer, a type of the material that's described in a help, or as an let's say IntelliSense help during the writing of the code. And here that's the name of the material. So here it's a waiting that it asks me set grade for concrete materials. So it's C 2025. Then the next line, I would like to also create a steel material. So it's S235. So materials are created in ADM. So we are here. Once we have materials, then we can create the cross sections. I mentioned that we are able to create the parametric cross sections. It means that we are, for example, able to create the rectangular cross section. So I need the unique identifier, the name, which will be visible in the properties in SCIA Engineer. Here I'm using the reference to the defined material. That's some identifier which tells the OpenAPI that it's rectangle. And then I have some array where I have some parameters of the cross section. So it's the width and height of the cross section. Here it asks me for input of the manufactured cross section. That means steel. So I can just write HEA 260. So I have cross section ready, and here I have some parameters which are describing my model. That are some spans or the directions of the parameters related to the geometry of the model. I will just put it like that. Once I have these parameters, I can construct the structural node. So I have the entity structure node, unique identifier, name, and coordinates x, y, z. Once I have created nodes, I can construct beams. So unique identifier, name, reference to the cross section, and here it's the reference to the points which should be used for the construction of the beams. Once I have beams, you will see it lately in a SCIA Engineer as in columns. I can attach the point support. In this version of OpenAPI, we are supporting just fixed support, but you can change it in SCIA Engineer as you want to have. So I have supports on the columns, and I can construct the slab. So it asks me for the thickness of the slab. It's here, and then it follows, let's say, the same logic as we have in a SCIA Engineer. So we have load cases which are included in some load group. That's here that I'm constructing some load group with the name LG1 with some type. Then I'm constructing load case, which is called LC1, and it has the reference to the load group. Once I have load case, I can create the loads. Here, it's related to the surface load. So for creation of the surface load, I need to know the value of the load. So I'm inputting 12,500 as we are working in basic, or let's say SI units. And once I have my model ready, here that's, let's say, the important moment where I'm refreshing everything what I did somewhere in the temp file or the memory of the tool. I'm saying related to the SCIA. Refreshing the model is empty because once I input all the things here, so I will do the refresh, and here you can see that it's refreshing.
Ricardo, I think you made a mistake because in the thickness you entered 0.25 instead of 0.25.
Yeah, that could be one of the reasons that it's based on the locale. So I will do the try once again. Once I will finish with the the explanation. So I will then run the calculation, and once the calculation finished, then I can ask about the results. Yep, it looks like that it's waiting. So I need to initialize the object related to the results, and then I need to create some, let's say, the container where I will have my results and some key for the results. So I'm saying that I would like to know the results for the load case with the name LC1, for the element type beam with this name, one-dimensional results, and that's the system local. Here I will get it, and then I will load results, and then I can display it. So I will do my my next try. With not comma, but with dot, as Adam mentioned. Here you can see an example which is related to the reactions. So it's the same as previous. That's the definition of case type, case ID, and entity type, which is, in this case, it's a node with the name N1 that I'm asking the reactions for point in a global coordinate system. And here, that's just basically related to the results related to 2D, that we are able for 2D results, for example, display the deformations in the local coordinate system, and then I can load it, and with some routine I can find the maximum deformation on a slab. So here I will switch back quickly to my presentation once I will wait for my second try for the demonstration of this tool. And sorry for my mistake with the comma and the dot. So back to the presentation. Here you have the links to the documentation and the examples. And here there are some, let's say, the key takeaways, which I would like to tell you related to this presentation. So our view on the parametric design is that it's mainly modeling based on algorithm. We have created our tool Koala, which is a plugin for the Grasshopper for the export of the geometry to SCIA Engineer through XML, or you can use it as a full circle that you will model it in Grasshopper, send it through XML into SCIA Engineer, calculate it, retrieve result, and do some other steps that we in SCIA Engineer 19 published first friendly OpenAPI, which can be used for creation of a model, for loading of such a model, or you can run the linear calculation and you can get results of linear calculation. And I will try to do the second round of my tool, so please cross your fingers, not the mistake. So almost the same results which I inputted. I will wait, and not to repeat the mistake, I will try to use the thickness of the slab of 1 meter, which is a bit silly, but I don't want to do the same. Okay. So it's quite busy. I will wait here to see if it's okay or not. In the meanwhile, we can answer some questions which we have in our box, which are not answered. Okay, that's the same as I did, because one question is my SCIA does the same. Thank you that I'm not the only one. Here you can see the results of my modeling, where I have the 4 columns with a slab with the load, which is 12.50 kilonewtons per meter. And if I will continue, it should also do the calculation on a background. So here you can see that there's something happened on the background with SCIA Engineer, and we can bet, let's say, on the results. What should look like if there is 1 meter. So the questions in the chat box: does the parametric modeling run with Dynamo? As I mentioned during my first part of the presentation, we created our own plugin related to the Grasshopper based on the presented API. You can create your own component in Dynamo. So if you are able to use in the Dynamo scripted components where you can include the code, then you can use SCIA Engineer together with the Dynamo. So I think we are at the end of our presentation, and then as you have been interested in the Python I can ask my colleague if he's so helpful as so willing to open the Python topic. So I will give him the presenter, so he should be able to show us his screen. Yes, we see a lot of terminal windows, Adam. So
so you see, this is the screen with my mouse, right?
Yes, right. That's the right one. So
yeah, but
please.
I need to choose another screen, this one. So now you should see the screen with
yes, that's the right one. Yes.
Okay, good. Yeah. So this is the same script as Jarda showed in his example. It's just simple, as you know, the Python is just simple text file. So now I'm just going to open the command line and execute that script. Yeah. So now let's start it. You see the feedback from that script. Maybe I will show also the right side. You can see that environment was set. So basically, we are somewhere here. On the other screen, the SCIA Engineer is starting. Yeah, but you can see only my screen with the terminal. But it's not so important because we can also run the SCIA Engineer as a hidden. We don't basically care about the graphical user interface of SCIA Engineer in this OpenAPI usage. So you can see that SCIA Engineer is started on my second screen. So we are somewhere here in the script. Now the project is being opened. Yeah, the template project that is specified on this line. You can see that I have the notification from SCIA Engineer server about some actions. So when some view on the project is open, I am notified in my program and I can react on it. Yeah. So now when the opening of the project will be finished, yeah, it's project opened. So we are here. And now I need to fill in the same data as Jarda. So I will use the steel grade S350, concrete grade C3037, steel cross section. For instance, I can use IP200. Now I am asked for parameters of the structure, the geometrical parameters. So for instance, the X distance of the columns will be like 4 meters. Y distance of the column will be 5 meters. And the height of the structure will be, for instance, 7 meters. Now the structure is being generated. Now I need to enter the slab thickness, so I will use the 200 millimeters and value of surface load. So minus, I don't know, 10 or let's say 2000 Newton per square meter. Yeah, so basically when I see my script, I am somewhere here. I enter the slab thickness and the surface load. And now on my second screen, you cannot see it, but the structure is being generated. I'm notified that the model was sent to SCIA Engineer. So we are somewhere here in the execution. Now you can see that the command for calculation will be run. Model is calculated. And then the rest of the script covers the loading of the results. Yeah, so for instance, I can see this is table. This is table for deformation of the structure for the slab. But as I entered, the low value of the load, here are the zeros because it's in the meters. Yeah, so it was my mistake that I entered so small loading. But for instance, here you can see that we have some for loop. This is kind of iterator that is trying to find the element with the highest deformation, and you can see that the exact number of the biggest deformation is this number. Yeah, so it's like 1 millimeter. Yeah, so this example basically shows that in very simple script, I can define some parametric model that is being created. I can parameterize materials, geometrical dimensions, and also loading. And then I can get the results from such a model. And for instance, I can perform several iterations to find the best shape of my structure, so that the the design will be the most efficient. Yeah. So basically, this is the whole script. So now I just hand over back to Jarda.
Thank you, Adam, for your presentation. And as I don't see any other questions in our box for the questions, I would like to repeat that all the examples are published in the GitHub repository, so you can easily access it and download it. I'll just once again show you it where you can find it. That's on the GitHub under the SCIA garage. You can go to the help, and here that's an example which Adam presented. And if I will go back here, it's an example, exactly the same one as I used in my presentation. And there is another one with the same content, with the same model in VBA and VB.NET. And the last one, which is related to the import update, it's here, and that's the description of the mechanism how to update the project, for example, from the IFC or from the XML. That's here very simple, one line with the specification of the type of the project and the path to the file. So we have description in the help and GitHub examples which have been also presented during this webinar. As we are at the end of the webinar, I would like to thank you that you attended our webinar, that you have an interest and ask us some questions. And I would like to also thank you, my two colleagues, Vladimir and Adam, for answering the questions, and Adam for the presentation of the Python script. So thank you, everyone, and have a nice rest of the day. Bye-bye.